in this talk, I'll kind of go through how does a DevSecOps see the supply chain and the security and risk implications around it. But at the same time, what are the challenges that are there? But proceeding ahead, I would also delve into what are the possible solutions, what are the technical operational challenges, and things like that. So before we get started with the talk, a bit of introduction about myself. Myself, Ankit Giri. I work as a director for pen testing solutions at BreachLock. Having said that, I have more than a decade of experience into the security world. Have worked for the likes of JPMC, Pfizer, PwC, Kroll, and TTND. Having said that, I've mostly been in offensive security or pen testing roles, leading pen testing teams, or in my last stint, majorly as a product security person, creating the processes and implementing the processes around security in SDLC CI/CD pipeline. So that is where the inspiration of this talk kind of comes from. So when we talk about supply chain security, there can be a lot of pros, like it brings in the integrated security into picture, wherein you can always reply or respond faster to vulnerabilities. You have a better collaboration with your dev teams. You have a better way of complying, like meeting the compliance. But at the same time, that also means that you are going to spend a lot of cost and effort or time when things are still in the initial stage. That also adds to the complexity of the whole thing, wherein initially the development was just focused around making things work, but then it kind of moves into implementing SBOM at different phases, like the code phase or like the deployment phase. So that kind of brings in that complexity. In terms of challenges, skill gap is also one area wherein this is something that has started to come into picture in the last couple of years. So you would still see a lack of awareness and understanding and respectively the skill. And then the development processes or deployment processes are at times very focused and streamlined, and there is always a resistance for change. So we'll talk about the over reliance on a solution like supply chain security using, let's say, SBOM. But let's go down into problems one by one and try and understand. So during my talk, I'll talk about the technology adoption, how it has been changing in the last few years, and then how it is kind of translating to something like a complexity in the supply chain. Also, having said that, when we are already adapting to new tech stack, we are adapting to new technologies, what kind of technical challenges that is bringing us into a mindset wherein we have to also secure or look at the security aspect of the new pieces as well, brought in. So that brings into picture the complete DevSecOps environment, wherein you have to look at the security side of things, but at the same time dev and the ops side, mainly like deployment and other things. And then at the end, we will dwell into some of the open source solutions that are already out there, or some solutions that come out of the box, just to get a better understanding of how this area can be tapped in terms of securing the supply chain better. So in the current world, the industry kind of faces challenge, because if we have to see, there has been an increased number of rapid adoption of technology, be it let's say infrastructure as code or containerization, Kubernetes. Also, a lot of development into CI/CD, and then a mixture of multiple clouds. But having said that, there have been a lot of recent supply chain attacks that has been happening. So that could include like Sisense Okta supply back in last year October, to something like a PyTorch framework that we will also talk about in depth. So there has been a very increased number of adversary and attacks and vulnerability and exposures accordingly in the same categories. But then we have to kind of get down to the root of the problem to first understand why these kind of incidents have suddenly started to spike. So, yep. And how exactly it is kind of increasing the complexity. So now there used to be times in the last 5-10 years where the infrastructure used to be something that has to be created, deployed, scripted, but then now we have started to move into a lot of automation in place. A lot of automation and scalability has made us to move more towards IAC. But having said that, once you have something like a script which kind of automates your IAC or infrastructure right from the code, but are we looking into securing the code at first, which is readily being consumed for creation of infrastructure? So any misconfiguration at the IAC level, it's not just at one place, but it is going to reciprocate to the complete infrastructure. So that is why that's more of a challenge on the technology adoption side. And then we are also seeing a lot of AI ML based development impact. So wherein we are already seeing a disruption in the development process, use of AI and ML based tools, solutions, or like ID or environments. But that also kind of exposes the whole security aspect to the fact that are we also securing the new things that we are seeing into the market, or the consumption of these tools. So not to name a few, but then a lot of coding environments now have started to give code suggestions right using AI, or like giving secure code implementation suggestions right in the development platform. But then also, like, is the backend in the AI also being tested upon, or thoroughly rigorously tested upon, to not have any kind of security vulnerabilities? And when I say security vulnerability, they can be risk from incidents like typo squatting, wherein there are a lot of open source packages which are now kind of the base packages are being manipulated upon to kind of pass on some malicious files or modules or packages, which essentially we would also get or deep dive into. So a similar case happened with malicious Python PI packages, which is more like there were two malicious packages, and they were found to be leveraging a trick called as, or a technique called as DLL side loading, which was essentially that they had made changes to the they have hosted them using a similar kind of a typo squatting attack, wherein the domain or the package name kind of resembled something to a very widely used py package. But then the files inside it, they were like malicious file. They had malwares which could also go back and start to establish a reverse connection to the attacker or adversary servers. So having said that, the packages were named something like np6 helper http test and np6 helper http, and they were downloaded already like more than 100 and 500 times. Now this came into picture by the reversing labs security researchers, wherein they shared about this type of attack chain that was consumed. And since these were packages out in the wild, right, they were available right on the internet for anybody to consume. And a lot of times while we are developing or deploying, our major focus is to make things run. And if the code would ask us to import some packages, we would just go ahead and do that, and maybe not even validating the sources, right? And what if the sources itself kind of called to some third or fourth party component, which themselves are not validated that way? So having said that, these new malicious PI packages, they were more like on the signed com server exe, but there were also some DLL files which kind of were making requests to the shellcode that was there in the backend. Now, having said that, we'll also see why exactly are we calling these as vulnerabilities, because while the sources were not being uh, validated at the same time, there were multiple reasons that this could have been avoided. So for that, we have to kind of understand the technique at the root cause. So one of the first root cause was that the ambiguous source resolution. So wherein the software component is not like the origin is not clear, or it is uncertain. So what if I am kind of pulling a py package and it has a dependency to some other packages in the backend? Then it will start to pull some similar packages, right? And what if I am pulling some packages and they are not able to find the right package at the first, and the command line will show me the suggestions for a similar set of packages that I can consume. And more so or not, like in majority cases, we would end up kind of agreeing to that because we want to just make things work. Having said that, that also involves like version trickery, wherein you can always have something like a legitimate software component, let's say by version 1.1, 1.2, and then you can have a typo squatted version of the same module with something like 1.3, which a lot of people would think that this is the latest version and they might start to consume that. So that is another reason why these kind of attacks are possible. And the third one is a namespace collision, wherein two or more identifiers in the program are kind of sharing the same name, which kind of leads to conflicts. And there are times wherein you would end up deleting the older package and you'll still consume the newer package. And like as we talked about the version thing, wherein the newer version might just be typo squatted way of another malicious package and not exactly the legitimate package as such. So having said that, this kind of takes it to a deeper problem, or wherein where all this is taking us to, right? So this essentially means that what can be the other ways wherein we can kind of look into avoiding these kind of scenarios? How can we get better at these kind of things, or how can we apply some countermeasures to stop these things from happening? So some of the things could be like a package name scrutiny and verification, wherever you are kind of consuming them on dev machines, on deployment machine, a lot of times also on your CI/CD level, wherein there are a lot of packages that are required to run your code. But then is there a artifactory management tool which kind of takes care of the right sources being only allowed and not publicly allowed sources to be allowed and consumed? Similarly, we can always route or move to a more private repository kind of a structure, wherein we are only consuming code or code component software modules from our own private repositories. Again, a artifactory management tool like that would come into picture and would be a better addition. Then something like a semantic versioning and digital signatures. Digital signatures have been there, existing for a long time, but then are we making use of these signatures when we are kind of using third party code, or code which we are consuming from the uh, World Wide Web, which essentially means that there should be a signature and hash check whenever you are consuming a software or component or module. And then to the next steps, wherein this talk would also deep dive into something like a dependency review process. So can we have something like a process wherein we are not only looking at the packages that we are consuming, but we are also looking at the packages that it depends upon? So what all prerequisite packages are required to run something? So let's say I wish to consume something like brew, but I need to have something like a Python installed on my system, and the Python requirement is, let's say, Python 3.0. So am I making sure that Python 3.0 on my system is already updated and it does not have already vulnerabilities on it? But this is just a generic way of saying this. We will deep dive into and see how exactly SBOMs would come into picture more into these areas. And then last but not the least, something like a continuous monitoring and vulnerability scanning. Now, this is not more from the application, dynamic application and network vulnerability scanning, but this is more towards the code and the third party code, or the software composition analysis. Some people also call it OSS. So that is more towards that piece, wherein are you kind of doing a vulnerability scanning on a continuous basis? Are any kind of third party risk and vulnerabilities also being managed upon? Is there a remediation cycle, remediation plan in place already for those kind of things? So that is also one major way of counter measuring or putting some countermeasures into place to stop these kind of supply chain attacks from happening. So having said that, uh, in terms of an industry wherein we have rapidly adapted to a lot of technology, but at the same time we have been faced with a lot of security adversaries for each new component, each new technology built. But then it can also be again in a better shape if we start to apply something like an enhanced dependency management. When I say enhanced dependency management, what I'm basically talking about is, we already talked about something like an automated scanning monitoring. We would also talk about the tools in depth at the later stages. But then, are we making sure of any sort of whitelisting and blacklisting in terms of code packages that we are using, right? So there can be some repositories which have been lying in the GitHub or public repository for a long time, and there can be a possibility that there are people who can still push code to it, right? So are we making sure that we are blacklisting those kind of outdated code packages, modules, or any sort of whitelisting wherein We are just relying on our artifactory management tool to allow the code to be consumed. And then something like a semantic versioning enforcement, which is essentially like, we are not just looking at, let's say, the Python that I want to consume, it should be starting with something like version 3.0. But then I'm also boiling down to the last level decimal place, wherein we are only saying that, okay, we will only consume 3.0.0 because 3.0.1 is not stable yet, or it might still contain vulnerability, or vice versa. If something like a 3.0.2 is the latest version and is already a patched version, it does not have any vulnerabilities because nobody has already forgotten the log4j and nuisance around all the Java packages that were already consuming something like log4j. So something like this would have already helped in proactively detecting something and stopping it from happening at such a large scale. So having said that, this essentially boils down to creating something like an enhanced dependency management. But have theoretically, this all sounds very good, sorted and simplified. But when it turns to implementing these things, what are the technical and operational challenges that we see today? So few of the challenges that I would like to talk about, and especially in terms of, let's say, building something like an SBOM, which is more like a software bill of material. If I have to kind of give a very close example of what a SBOM could be, it can be considered something like, uh, let's say we are a factory which produces software. Let's just correlate or give an analogy to it. If we are a factory that kind of produces something like cornflakes, or a combination of different grains coming in together, and each grain would come with its own expiry date, the source and supplier. So each supplier will define that, okay, I'm passing you wheat, and this wheat is only good for, let's say, like next 30 days, but that would not apply to millets. So similarly, in a software composition industry wherein there are different vendors, let's say we are consuming Google Map API and other things, what is the vendor saying about their own software? So now SBOM is very easily generated, they're very easily available. But has that awareness come into picture wherein we are already started to make a standardization in those areas? So the answer would be a bit of a no at this point of time, because there is yet to be a lot of standardization that has to happen. So a lot of tools, paid tools, have already started to move to Cyclone DX and the latest version around it, 1.5 or so. But then they are still kind of very fragmented into use of different SBOM standards. Having said that, this also kind of puts an impact on development, because it would add another layer. So if my CI/CD had 4 stages, now it might have 5 or 6 stages. That means that the development might go uh, down a bit slow. It will get into some bottlenecks in terms of resource and utilization. So that being said, there could be more problems on the SBOM side, wherein there could be cases wherein the quality itself of the SBOM is not up to the mark. So we might be generating SBOM, but what if it does not meet a certain quality standard? Having said that, we have already talked about the standardization piece and quality piece. So what are the metadata challenges? So when I say metadata, all the information inside a SBOM, which is more like what are the component, what is the version, are there any vulnerability for those version and component? So there can be cases wherein a Java library might have different fields to something like a JSON based component might have different field in its metadata. So mapping them, bringing to them to a same format, or getting the right information from them. Another challenge that I can think of is the ownership. So there can be cases wherein there are code that is already third party. So who is going to take the ownership? Who is the author on the code? Who is the author for a particular module? So these are the areas which is still more of like an technical challenge in today's time. With a lot of standardization and normalization, we are heading towards solving them, but we're still very new into these steps. Now, some other pieces wherein I see a lot of technical and operational challenges is the changes in the workflow, right? And how and who takes the responsibility of building, deploying, and securing these SBOMs? Is it the dev team? Is it only the security team? Ideally, it should be a mix of mix of multiple teams taking responsibility, more like a shared responsibility model. And then also bringing in new tools kind of brings in that caveat of having education, training, developer complication, policy updates. So a SBOM in place is only as effective as how good updated and how good of a policy had it been applied with. So, and we have already talked about the resistance to change. There has been a traditional work practice or a change management process. How easy would that be to integrate it into right into the development and operation model? Having said that, because let's say the development practices were being done on GitHub for the last 3 years, and now we are just moving to Bitbucket. Would our whole model would adapt to the new environment, or would it require a lot of over engineering, lot of effort to be put in to be able to sail through these kind of scenarios? Having said that, we already have a lot of open source solutions, and I would also try and jump into some of them, but I'll talk about few of them first and then maybe move into some of these. So the software solutions that I talk about, there are open source solutions. So there is a big framework that is being backed by OWASP called as dependency track. There is a very wide community based support, and there are very frequent updates and feature that gets added to it, plus something like a vulnerability management platform like Defect Dojo. That can be like a perfect combination of a framework and a vulnerability management tool. And you can always consume all of your CI/CD tools, SAST, SCA tools, and then also like your code repositories kind of generating SBOM and just pushing them onto these framework and model. But then how about these tools also getting the essential vulnerability data, which we also called as something like a VEX? Now, when I say VEX, there are different scanners that comes into picture, something like SIFT, Trivi, right? They can scan your code for vulnerability or your SBOM for vulnerability. And then there are tools which kind of do all of this. So Cyclone DX is more like a SBOM generator. Fossa is like a open source vulnerability management platform, but that it also takes care of the OSS or the SCA, software composition analysis component. And then there are dedicated tools like the SBOM tool. So today maybe I'll try and go through one of the cases wherein there is also a tool called as Cube Clarity. So this Cube Clarity is mainly something like a uh, I'll give a brief about Cube Clarity. It's more like an open source vulnerability scanner for detecting and managing SBOMs, but majorly into the Kubernetes side of things. Now, when I say Kubernetes side of things, I'll give a quick demo of how this works, what all information can you see. But at the same time, it helps us secure a lot of cloud native application. And at the back end, it supports scanners like Sift and Gripe. You can also have multiple vulnerability source like GitHub security adversaries or vulnerability database, or Snake's own database for vulnerability management. But having said that, this kind of consumes all the container scanning and runtime scanning right from Kubernetes. And one of the so yeah, these are the ones that I was talking about, like the NVD and the GitHub advisories, which it can consume vulnerability information from. But at the same time, it also contains something like an open source container scanners. So Trivi, Claire, Gripe, which also essentially scans things like I would say IAC. So a typical vulnerability exchange data or format would look like something this, which is essentially like what is your package name, what is the installed version, is there a fixed version? So let's say 2.2.4 is installed, but there are fixes in 2.2.5. It will be listed here. And then what is the type and the vulnerability and severity? So having said that, I'll jump straight to the tool wherein we will talk about how essentially things look like, and I'll try and do something wherein we can look at how does the whole information looks like on the fly. So I'll quickly go to the runtime scan. So what I've done is I have deployed something like a Yelp, which is more like a restaurant management dummy application used for lot of uh, research purpose, or let's say testing purposes or a QA purpose, just to learn or run things. So that's like a dummy application. So what I'll do is I can select the namespace. So I've already deployed something like Kubernetes. So I'll quickly select Yelp, which is my deployed application. I'll click on start scan. And while it is scanning, Couple of things that we can see already is we can see that we can scan dedicated namespaces. We can also scan different applications. We can create or add it right on the Kubernetes cluster that we want to see the vulnerability and SBOM information on. So it will give you an information about each step. So if the scan has already started, what is the scan time, what is the progress? It says that it is scanning. You can always see something like a schedule scan. So you can also set up schedules around this. I'll also talk about different component that the tool comes inherently by default. So there would be a dashboard. We will jump to the dashboard once the scan finishes. Then you can see the applications that you have on each of these. I would say each of these Kubernetes cluster. So just taking a break because the scan is already completed. So as you can see that the scan is complete, the progress is 100%. You can already see the vulnerabilities divided in terms of severity. Now, when I say they are divided as per severity, that gives you a very good idea of how you should be looking at remediating it. How would the vulnerability prioritization would take place? And then we can always filter vulnerabilities based on the severity and put specific filters if we want to see only the vulnerabilities for each application or resource or package. So I'll get a better idea. I'll rather go to the dashboard now because we have all the data initially. Since I have not run a scan, you wouldn't have been able to see all of these data populated here. So what I'll show now is, so these are the set of vulnerabilities that have been identified for each vulnerability, each severity. So you can definitely click on any of these and it will take you to the set of all the vulnerabilities. But going back, we'll stick to the dashboard first. You can see that for 5156 vulnerabilities, you can already fix 2855, which is more than 50%, right? And then it also gives you an idea of what is your license compliance like. So how many of them already have a license out of the total count? So there are like 590. And what is the package count for each language? So what you can also create a attack surface from a code consumption perspective, that what is the core of your programming or the coding language that you consume. So in this case, let's say it's Go, and the second most might be Ruby. So you can also click on these and see what are the vulnerabilities on each language that is being used for building your application. Now, having said that, this lays down 4 application and resources for each application and total number of packages. I'll deep dive into these as well in some time. So when we say application, this is mainly Yelp only, but Yelp has 4 component to it, which essentially means that it has a UI component, it has a database, backend database for storing all the information, and then it also has something like an app server and a Redis server. So this is like the top 5 vulnerable element that it shows, and in resources you can see all the packages with what are the vulnerabilities and the version for each one of them. And then you can always see a vulnerability trend data, which is more like a timeline graph which talks about something wherein you are more of looking at what has been the trend. So this is more like in an dynamic or an iterative environment wherein you are doing development. You can see in the last week, last month, or like back in time, what has been the trend with the vulnerabilities. Are you fixing them? How has been your remediation effort going? More from a accomplishment or achievement perspective. So I'll go to application. As we talked about these 4 application, you can always see that the application type is pod because we have deployed it in Kubernetes. There are IDs for each of these, what is the environment, and these are the vulnerabilities. This also gives you a better idea of do we want to uh, filter it through sys docker benchmark, right? And what are the number of application resources and the packages. We can also edit and delete the application, and since we just have one dummy application, I'll go to the resource. Now the resource name again contains information more of, because we are kind of using Yelp database and a Redis and Istio for proxy. So these are all images that we are making use of. And for each of these vulnerability to translate and get into our our ecosystem, wherein how we can quantify these vulnerability. The SBOM does not include any vulnerability information. It is more of just containing information about the component, what is the version being used, and that gets scanned by something like an SBOM analyzer. So as I mentioned, like Gripe or Sift, which essentially runs a scan to check if these resource does the particular version has vulnerabilities out there defined publicly from different sources. So we already talked about those vulnerability sources like NVD or GitHub adversary, and this is where it gets the data pulled from. I'll go back to packages to talk about each of these packages in these application. You can always put a filter and see only basis of, let's say, a particular application. And if I select let's say Yelp, my bad, if I just select Yelp and I say okay, okay, we might try something else wherein it is able to kind of filter through the vulnerabilities, but then we can always kind of still sort our data based on the vulnerability. So you can also see the packages which does not have vulnerabilities as such, which is a good indication. And then you can always check if the license is also there. So you can also filter out all the packages you are consuming, but it lacks a license information. So this also comes in handy in terms of compliance adherence for third party code consumption. Are you making sure that the licenses are defined correctly and things like that? I'll just give it one more try. Now this is more like, because it is still like a dummy application, and okay, I'll put a critical like a severity level high, and now you can see all the ones listed by the severity. So they should have at least one for high. That is why it will get listed. Otherwise, it will not get listed in our filtering. Then we talk about vulnerability. So this is not like uh, it is pulling all the data from NVD, but then it keeps on refreshing and replicating that data right into the tool, wherein each of these kind of works or gets into things like what are the CV that we can pull, but only pertaining to the packages that we are consuming. So you would find a package name to each one of them. This is not all the data that the vulnerability database has, but rather for the packages that we have in place. So this is based on severity. So I've gone to the least severity now. So it dates back to CV from the year 2010, and being in latest like something like 2022 that we can see as well. Okay. All right. So I think it kind of keeps so this is still in on my local machine, so it can uh, start to slutter at times, or it start to give certain error, but this is fine. We have mostly covered the major pieces that we wanted to understand from this. I would not limit this to only this, wherein I can also give you an a brief of what exactly or how exactly this becomes essential. Going back to my presentation, and before I move to question and answer, what I have seen from my own past experience is that uh, all of these this being said, there is also an additional overload of something like bringing a new tool into place, wherein we are already consuming a lot of tools from the perspective that we have a SaaS tool, we have a dash tool, we have something for our pen testing, we have a vulnerability scanning tool, we have multiple tools already. So definitely it kind of brings into picture an additional tool and overhead of managing that. But the good part or the good side is a lot of your existing tool itself would help you generate these S bombs. So for example, something like Cyclone DX is is it has Jira plugin to language framework based plugin to all the ID based plugin, which helps you generate SBOM for Java libraries, Maven, Spring, and others. And at the same time, you can, if you're already having something like a SCA tool, let's say be it Checkmark, Snake, or any other vendor, or you have something in terms of artifact management tool like a JFrog, that can still help you generate all the SBOM for each code component and library, maybe even based on repository. You can also do it based on each deployment level, and you can do it at multiple stages in a pipeline, and you can keep on reflecting or kind of generating them, let's say ideally in a stage wherein for each release, but then bringing it more down to very basics in a form that you are doing it at least daily. So SBOM generated daily still kind of keeps you right in the front seat, wherein the vulnerabilities are getting detected each day. But if you are scanning your code for the source component and the version based vulnerability out there in the market, for every 24 hour, there is a high likely chance that you will be able to detect it very early before it getting into the phases wherein your pen test or something like a vulnerability scan would have picked it at later stages when it has already gone into deployment or a production stage, which essentially means that you're already reducing a lot of time, which essentially means effort and price accordingly, because you're not going to have to go back and roll back from higher environment like production to stage to QA and dev to fix those issues and then go back to up the cycle and do everything to sanity check, QA check, but rather you're fixing things right in the base while you're developing the code. So having said that, this was mostly from my side. I'll open the forum for question and answers. So any question and answer I'll be happy to take.
So we have one question from the chat. Would one solution to these supply chain attacks be for companies to self-host their own components?
Okay. Yeah, I mean, I get it. So I'll try and answer that in a way that uh, yes and no both. So definitely the ideal or the clean slate scenario could have been something like deploying all the code or using all the code component that is already existing or developed by the company or the organization. But that is not essentially always possible as well, because in today's time there would be like, even if you have an e-commerce application, you would definitely be consuming somebody's payment APIs. If you are an application which makes use of location in the background, let's say a ride hailing app or something, you would definitely be consuming something like an like a Google Maps API. These are some examples, but then it is very hard in today's time to restrict the whole code creation and consumption mechanism to being just limited to the own organization and not consume any third party code. The better way of doing that would be like consuming the code from other sources as well, but then keeping a check or like keeping a check to securely consume it. That also gives me kind of a interesting picture in mind, wherein if we had something like an SBOM already deployed in organization, like an SBOM scanning vulnerability management solution, let's say dependency track or something, when log4j came in, we might restrict our code, right? But we might still be consuming code. What if I'm making use of a SaaS scanner, which essentially consumes something like a log4j in the backend, right? So if we would have something like an SBOM and we would have created a separate section for our vendors or the third party code that we consume from outside, and we have like implemented or kind of fed our system with their SBOM, which now is more like a also a mandate from US executive order. So which essentially would have meant that we would have been able to get a very early alarm for the same thing. So I hope that answered. Any follow up on that? I'm still also kind of reading through the chat. There might be a bit of a delay, but then any other question I would still kind of be happy to take. Okay. Uh, So, by the time I wrap up, just wanted to let you know that I can always be found on LinkedIn, YouTube, or like I even have a About Me page wherein you can read more about my earlier or other conference talk and research more into web, IoT, or cloud pen testing space. And I've also kind of been to other conferences wherein I have put the recording on my YouTube channel. So that is why I will also add a lot of references in the slide deck that this can be referred to. if people want to go back and get to the drawing board to understand how they can implement SBOM in their own ecosystem. So that would be more like a reference to start with. So with this, I'll still maybe say or wait for like couple of minutes. Otherwise, we would be good to close.